Hello, everyone. Well, maybe one of these times this will work. We just wrote this code a couple days ago, and this is what happens when you just write code. Well, we can always do that via old school. Okay, hello everyone. Let's get started, I guess. So today I'd like to talk about HTSQL. HTSQL is a high-level query language for doing fairly complex queries and answering business inquiries that would otherwise be difficult to code in SQL. You can think of it as kind of like, if you're familiar with CoffeeScript, it's something that compiles into SQL. In that way, it's very similar to an ORM. And an ORM would be, an ORM basically is working on insert, update, delete, making that easier, and providing a high-level wrapper over, a really strong relational database, such as Postgres, in order to do screen development and that sort of thing. So, in the case of HTSQL, the target is to create a set of to allow complex business inquiries to be answered. And what I'm going to talk about today are how business inquiries can be thought of, what a target audience, what a business analyst would be thinking about, and then I want to point out some limitations in SQL, how HTSQL addresses them, and just give you an idea about the kind of things you actually can do. So anyway, my name is Clark Evans. We started a company called Prometheus Research about 7 years ago. We do medical informatics. And so our company, HTSQL was scratching my own itch because as we grew, we had a lot of medical researchers, and all those researchers had complex data analysis problems. We had tens to hundreds of tables in various schemas, and we had complex requests in saying, please show me all individuals with medical experiments such that there's a correlated record for here, and there's this, and there's that. And these SQL queries got to be very complicated very quickly. And so as we grew our company, I had a really hard choice. Either I could find developers that knew a lot about SQL, but had to learn about medical informatics, or I could find people who were specializing in medical informatics and teach them SQL. Neither was very good, or I could find someone who knew both, and those would be exceptionally expensive individuals. And the typical problem is that you either have a domain expert who actually knows what they're doing and in the problem domain, or you have a developer who knows what they're doing in terms of SQL. But those two, you need to get them collaborating very tightly. And scaling a business this way was not really an option for us. And I had knocks on my door, my query won't work, and finally I said, oh no, okay, I'm done with SQL. I have to do something. So I started to write a query builder on top, and in order to have the query builder, this was the web, the start of really the Web 2.0 stuff. And my query builder was initially a bunch of screens, and it made a URL, and then I was not covering all, it was not a full-blown language, it was just some kind of set of hacks that allowed me to do common queries with a visual query builder. And it grew from there, and it went on and on. About 5-6 years ago, we had given these directly to users, this visual query builder, and the visual query builder would make a URL and submit it, and it would be translated into a query and then execute. And I had a really cool experience where I was also a system administrator at the time because you play lots of hats. And I had someone who was clearly experimenting with the URLs, and I thought was a hacker who had somehow gotten access to someone's lab and was trying to break into the system. So I firewalled off the IP address, and then a few minutes later I got a call, and it was like, hi, hi, this is, like Warren, and I have this grant due tomorrow, and it's Sunday at 10 o'clock, and your database is down. Could you help? Because I gave him my cell phone number. And he said, well, and I said, well, the database isn't down. It's working great. He's like, no, I can't access it. And I said, what's your IP? And I'm like, why are you writing the URLs directly? He goes, well, your visual query builder is nice, but the bottom line is that I can bookmark these things. I can write a Perl script that rips. I go, you write Perl? He goes, well, not really very good, but yeah, because I'm trying to pull all this data and do some statistics. So I opened up the port and I watched him experiment with the URLs, just really in awe, and just seeing how clever this gentleman was. And so I really started to think about, gosh, maybe these are the kind of users that I want to target. And and this was our first big lab, and I was like, in every lab there might be one of those. And sure enough, as time went on, there were more of those. There were very smart people who weren't really programmers. They were accidental programmers. They picked up what they had to do. Now, I must say, those kind of people I don't think would have a chance with SQL. Not to be too blunt, but that's also why a lot of GUI developers use ORMs, because they really, if you gave them SQL, their eyes would glaze over and they would have a very hard time. I'm not picking on SQL. I just think that there's particular domains where a higher level language actually is more appropriate. So anyway, I'm going to talk about that today. So this is written. If you don't know me, I'm the person who dreamed up the abomination called YAML, which is some people run into, which is a file format.
I gotta go.
Oh, you got it. Fine. Yes. Right. And Kirill Semenoff is my technical partner, and he's the one who wrote PyYAML. And he and I have been working together for this for about 5 to 6 years now. And it's just, we've gone through iteration after iteration, field testing it with analysts, and this is what we got. So what is HTSQL? It's a web gateway for relational databases. Relational databases? Ooh. It's a navigational query language, and I'm going to talk about what it means to be a navigational query language really soon, because I think it's really important. It's kind of a complement to ORM. If you have a business app that's using an ORM for CRUD, and you want to do some reporting, complex analysis, or a business inquiry comes in and says, hey, how do I do this? Rather than dropping down into SQL, you may want to try this instead. I think something that popped out over time is that this tool became a way to describe and socially share data sets, and that I didn't anticipate. So I have our developers now in our company don't write queries, and our business analysts do. And when they say, hey, I'd like a screen, here's the mock-up of the screen. I want this part done by this query, this part done by this query, this part done by that query. And it really facilitates the communication loop. Instead of saying, oh, I'd like this data and that data kind of described in humanese, which the developer has to translate into SQL, we just don't do that. Our data analysts, who are domain experts, work directly with the users to fashion the queries, and then they just put these things in a copy and paste area. So, and finally, I really think of it as a data access tool for accidental programmers. At least that's the ostensible goal. And reaching it is hard. So I'm not going to claim that I've reached it, but it's the stretch goal that I think a tool like SQL started out trying to target, and to which we've been targeting. So in summary, it's a query language for answering business inquiries, and I think quickly and correctly the first time through. So let me move on. More technically, HTSQL takes an HTTP request, converts it into SQL, executes it in the database, and returns results in various formats. So it's a very simple middleware component. It will web enable on your virtual private network behind some kind of user password restriction system or anything else. It will grant access to particular users of the database, and it's fairly direct because you can generate queries. It will prevent a lot of. It does add a minor layer of security, meaning that not every SQL query is possible, and there's an equivalent. There are the equivalent kinds of things that you could do. For example, if you had an SQL injection attack, you could probably have an HTSQL injection attack. So you have to be very careful about cross-site scripting and all that kind of stuff. So this thing isn't going to solve any security problems, but it does actually provide a web access layer if it's appropriate for your user base. The other thing that you could do is add a front layer. A common way to solve security restrictions for a more broader user set, ones that you don't trust to make queries, is to go out and make a bunch of URLs which then are associated with templatized queries, and then those are run, and then you open up those to the broader audiences. So this is the tool primarily meant for trusted users, not necessarily a broad audience. But they are opened up to data analysts, and your data analysts are probably trusted users, because if you don't give them some kind of way to access the data, they're going to ask for a data dump. And as soon as a data analyst asks for a data dump, they're going to modify it. And as soon as they modify it, they're no longer using your database. And that's a bad thing. So All right, one of the cool things you can do with this, so this is an application of HTSQL, is you can make dashboards quickly. Here is an interactive dashboard where, against a simple schema, you can pick a school, it lists departments, and then if you click on a department, it'll show you all the courses listed in that department. Fairly simple dashboard. What's on the left is the entire source code for that, which is a mixture of HTML with embedded HTSQL queries. And there is a little JavaScript tool that will that basically handles the event management between the components. So this is one way you could use it. It's not the end all be all. But if you want to get up dashboards quickly, this has turned out to be a great tool to do that internally in our company. So here is the so here's kind of the screenshot of what the dashboard looks like, and here is the source code in depth. So the first thing that it does is it has a select school. You have school, and then you have a query. So this does /school, return the code and the name for the school where there exists a department. There happen to be schools in this data set which aren't associated with departments, and since your goal is to look at courses, there's no point in showing them. Then for departments, we have an input field so you can filter by department name. And this then is the HTSQL query that says, give me departments, give me the code of the department, the name of the department, and the corresponding school name. And then the variables here, school, refers back up to the ID school. So it's a little simple data binding network. And as I said, that's about it for a fully interactive dashboard. But let's get back to query languages in SQL and really the guts rather than the applications. So why HTSQL? We wrote it to enable data analysts to self-serve. I didn't want them lining up at my desk in the morning saying, my query doesn't work, why? And really, I found that data analysts can do simple joins, but they often do them incorrectly, and it's difficult. As soon as you get any modest complexity, either you have to review it, or they're at your desk asking for help. And I wanted a self-service system, or our company wouldn't have scaled. Technically, it's like an ORM, as I said, but instead of CRUD, it's focused on reporting. And socially, it's a mechanism where our programmers are not writing queries at all. They're actually getting them from the data analyst who can review the queries with the user interactively and make sure, is this the data set you want? Yes. Okay, great. They copy and paste that, and then all the queries go up. One thing that was kind of cool in terms of sharing is we actually had a user who asked for a meeting and said, hey, I want to do this. And it involved like 4 people, so we scheduled it. So, okay, the next time we can meet is next Thursday. And it was pulling together 3 senior people, a primary investigator, which is a senior person in a research grant. They're very expensive people to bring in. And about a day later, one of the data analysts said, hey, if this query gives me what I want, we don't need to meet. And we looked at it, and sure enough, it met the requirements. So we then just said, hey, let's cancel the meeting. And that really was, I think, a watershed event about 2-3 years ago where more of our data analysts, or more of our customers who are data heads, were using the tool directly. So this is a shared language. You have programmer developers, business users, and business analysts, and you have a communication problem. They use different reference documents, different languages, and when they're saying different things, they mean different things. The goal that we had, or what we found out, is that if you actually are sharing the URLs, the queries can get emailed. Test cases, when you email a query, they can go right in your test case system, and you can record the expected results. And the queries are concrete evidence of exactly what the data analyst intends, which can be verified with the user interactively and then handed off to a developer. Okay, so that's the introduction of what HTSQL is. I want to actually roll all the way back to 1974. And this is a section of the quote from Chamberlain and Boyce, when in their paper where they introduced SQL in Ann Arbor, Michigan. And they talked about first a class of users which absolutely require a GUI, are not that interested in tweaking. But it went on, and it talked about a large class of users who, while they're not computer specialists, would be willing to interact with a computer in a reasonably high-level, non-procedural query language. Examples are accountants, engineers, architects, and urban planners. This is the class of users that SQL is intended. So this is SQL's roots. They were targeting the same kind of user that I'm targeting with HTSQL. So what I really wanted to know is, why aren't those users using SQL, or why aren't they able to use SQL? Because this was the target, this was the goal. And I think SQL became a great programming language for developers who know what they're doing. But I don't think it's become a ubiquitous language. And I'm not arrogant enough to think that I could actually accomplish this, but I'm arrogant enough to try. So, all right, so what I want to talk about in the next 20 minutes or 30 minutes is why relational algebra is a poor fit for this class of users. And I think that's the fundamental problem. And ORMs don't use a relational algebra. And I think that there's a reason for it. Codicil did not use a relational algebra. And I think there's a reason for it. So the primary problem, I think, is that they have a poor choice of elementary operators. When you're doing data inquiries, the business analyst is interested in concrete objects. They're interested in courses, departments, schools. They're not interested in sets. And they don't understand Cartesian products. So the initial set of elementary operators is problematic right out of the gate. Teaching a accidental programmer to think in terms of sets is hard, especially when you're talking about set operators. So it's difficult in coding business inquiries, primarily because of this. The simple cases, the simple queries pay these prices for extreme flexibility. I mean, once you get into a set algebra, you can do some really cool things. Unfortunately, if you're just trying to take one table and some account, it's a lot more complicated than what you might want. Finally, because the fundamental operator of SQL is a Cartesian product, anytime you try to relate data, the initial default is an incorrect query. And your where clause, it's the burden on the person writing the query to fix it. So you're starting off with a wrong query as your bootstrap. I mean, that's the first thing you do. Like, let's say you want to collect information from school and departments. The first thing you do is a Cartesian product. Now you have, now if you just wanted one row to represent a school, you have to fix that. You have to use a group by properly. You have to do a projection. So anyway, that I think is the crux of it. So let me move on and talk about an alternative. So what Codicil had before SQL, and Codicil, by the way, was targeting the same kind of users. Their goal was this COBOL programmer who would be a machine in a cogwheel who could, produce lots and lots of code, and they want to industrialize software production in the 60s. And Codicil was an effort to do that, business-oriented language. And ODBMSs were very similar in their approach. ORMs are similar in their approach, and these new NoSQL databases are similar in their approach. By a navigational model, what I mean is that you say, hey, I want schools, and I want to navigate over to associated departments. It's very different than a Cartesian product of schools cross departments. It's a navigation. It's thinking about, I'm here, I found the school I want, now go give me the corresponding departments. I found my department I want, now go over here and give me my courses. So these are the kind of pathways that you can think that users know their domain objects, and moving between them is a fairly intuitive construct. And the fact that navigational model is used for almost everything but SQL is I think something that really should be considered and thought about. So what navigational models do is they automate tedious constructs, joins and casts. They keep collection. What's wrong with ORMs is that they're not collection based. So what you want to do in a navigational model, a navigational query model, is keep collections. You want to be talking about large groups of domain objects. You don't want to be talking about individual records, which is what ORMs are. So finally, you want to keep predicate logic, aggregations. You want to keep projections, but as a separate operator. And I'll get into that in a little while. Basically, these are the kind of goals that we wanted in HTSQL. We wanted to keep the good parts of SQL. Set-based processing, the ability to do complex aggregates, complex predicate logic, projections. So when we started to work on SQL, I said, hey, should I just write my own database? And I said, no. A lot of people went that direction. That's the NoSQL direction. I looked at Postgres, and I was an avid Postgres user. And I said, let's just wrap this and let Postgres do all the heavy lifting, because the heavy lifting is hard. So, all right. What I'd like to do is go through a bunch of business inquiries on a fictional schema. I'm going to show the SQL query, and I'm going to explain why it's not that great, what an alternative would look like, and we'll go from there. So in our example schema, I just imagine a university. It's kind of fictitious. The top level table is a school. Schools have departments, and departments offer courses. So it's a straight 3-level hierarchy. But this hierarchy forks over, and the schools also have programs. So in this is a very, very simple schema. It's not particularly great. I mean, most schemas are a lot more complicated than that. But the idea of going down through 3 levels of navigation, a 3-level hierarchy, very common. Having a hierarchy that splits, also very common. So so this is the regression schema that we have. We also need other regression schemas that aren't this simple. But so the anatomy of an HTSQL query. Let's go through this. First of all, there are 3 things that a navigational model has rather than making a Cartesian product and doing sets. The first one is you have column selections, right? Which is equivalent to the SQL that says select columns, or should be equivalent. So in this case, our query this is actually a complicated query. It's asking for distinct degrees, and for each degree, count the number of navigate down to program and then over a student. The student is a subtable of program that are associated with that degree. So there are 3 parts of a query. The first one is row definition, and this is by far the most important one. When someone does a business inquiry, you want to know exactly what are you getting. What does each row represent? And that's where SQL has the most difficulty. Because in SQL you're starting off with a Cartesian product, and you don't know what an A cross B is in the real world. So row definition is kind of important. In this case, we want a projection. The program table has a column called the degree, but we don't want to return programs. We want to return distinct values of the degree column. So that's the very definition of what a projection is. You're actually making a brand new relation out of an existing one. So it's similar to the distinct operator in SQL or the group by operator. And we'll talk about group by in a bit, though. Then you have a column selection where you say, hey, for each one of those rows, I want these corresponding objects returned. Rows from these corresponding tables or aggregates. In this case, there's an aggregate. Finally, so now you have a set. You know what each row represents. You know what associated data you're returning. Finally, you probably want to filter it, saying, oh, I only want these rows. So that's basically the 3 parts of a query. And I want to go through and show why SQL doesn't have that breakdown. The first problem is SQL conflates rows and columns. So in our example schema, let's say, please list departments. This is what the business person wants. For each department, show me the corresponding school's campus. So the SQL query that you do is you say, hey, select the code, the name, and the campus from department, join over to school, and join on that join condition. Really straightforward. If you look at the query, though, you're actually doing a Cartesian product from department to school. And then you have to actually make sure that you're joining correctly in order to ensure that each row represents a department. It's not obvious unless you know what the foreign keys are, and unless you know how you're joining, that you're actually getting department rows. And this is a simple query. So basically that's it. The problem right off the gate is that the from clause doesn't just pick rows, but plays a role in choosing the columns. So you've completed. The from clause doesn't define what each row represents. It's needed in order to select associated rows. And so that's the 2 operators. Because of the Cartesian product, the mental model is immediately divergent. In HTSQL, similar to an ORM, you just say, hey, I want department rows, cleanly obvious. I want the code, the name. I want you to go over to school and grab me the campus. Now, with a syntax like this, it's fairly simple, or fairly good to get errors. For example, each department has more than one course. If you would have gone department code name course.credits, you would get an error. And the reason why is you'd get a cardinality conflict, because there are more than one courses for the department, but you're not using an aggregate. And that's important. So anyway, so the navigational translation separates the row definition from the column selection, and that's the key thing that you need for business inquiries, or at least I'm asserting you need. Let's go through another one. For each department, return the department's name, number of courses having more than 3 credit hours. So here's a pretty good query. So you got this one actually is cool because it actually solves the problem that I previously talked about. You know what each row represents. Look at the from clause. Finally, it's obvious. If you look at that query, you know you're getting department. One row in the results set represents department. But the problem is here is that now you're conflating the join clause over to course, which is limiting the number of courses, with the actual filter condition you want, which is you only want courses with greater than 3 credits. This conflation now is confusing. What exactly are you counting? It's not clear unless you actually know, once again, know the schema really in depth, and you could, if you don't get the join condition right, you have an error. So the SQL encoding uses a subquery to avoid row and column conflation. However, the where clause conflates the join logic and the actual business logic. That last query is actually really easy to read. This is what you're going to find in production now, because the other one, quote unquote, performed poorly. And in this case, you have the worst case of both worlds. You're conflating the join condition on the filter, and you no longer know what each row represents, unless you do a detailed analysis of the schema and the foreign key constraints. So that's actually a very common and simple query. This is where even beginner and analysts, they throw up their hands that you'll have them coming by your desk, even for ones like this. Here is the HTSQL equivalent. You're returning departments. You're returning names. Since course is a plural object, right? You have more than one course per department. You need an aggregate. The aggregate in this case is count. If you didn't have an aggregate, it would be an error. And the join is implicit, and the filter is exactly the filter you asked for in the business inquiry. Number of courses having more than 3 credit hours. So this is kind of where the navigation is also kind of clear, because you're going from department to course, and you don't have to think about making a Cartesian product and then limiting it. All right. Now let's talk about projection. Projections are kind of hard in SQL. See, everything in SQL is a projection as soon as you're joining, because the first thing you do is you do a Cartesian product, and then you project to get the rows you want. So in the previous examples, you would join department and course to get a cross product, and then you would project that set to get departments back. So let's talk about this one. How many departments are there by campus? So campus is not a table in the system. It's a distinct column. You want distinct, it's a field of the repeating group in the school column, or in the school table. And in this case, what we want to do is count the departments. So we have to go select campus, count the departments from school, and we do the join condition. This is often missed. The campus is null. If you get, if you're asking for campuses, the cases where there are no campus is that's not part of the business inquiry, and then you're grouping by campus. This is actually not bad at all, because at least you have a group by there to where you're projecting by campus. But it's actually not bad here at all. But however, if you did the count of if you left off campus and you were actually doing by school name, you would be using a group by, even though you're not actually projecting from the user's perspective. You're not actually making a new data set. I don't know if that's clear or not. An alternative inquiry would be how many departments by school. You would still need the group by in that case, even though you're not actually making a projection, even though you're returning school records. So anyway, what I wrote here is the SQL query is not clear if the group by is used to produce an aggregate or if it's used to actually project. If you replace school.campus with school.name, you're actually not projecting anymore, but the query is almost identical. So completely different business purpose, almost identically structured query. So it makes it hard to know if you got it right. Once again, you have to know the schema and the join columns and all that kind of stuff. The HTSQL approach is to keep the projection completely separate. So we have a caret, which is a projection operator. Anytime you want to change the row definition, you use a caret in order to say, hey, this is the kind of row I want. So in this case, it's school caret campus, which means I want distinct campuses from the school table. And then, what do I want? Well, I want the campus. Then I want to count. Remember, we're talking about campuses now. So campus has now a virtual relationship. It's a one-to-many relationship to school. What am I counting? I'm counting for each campus going to the schools, then I'm going down to departments. So the projection syntax is, or the projection operator is what we worked on the last 6 months, and it took us a long time to get this correct, or what I hope is correct. So, okay, let's do a really fun inquiry. For each school with a degree program, return the school's name, the average number of high credit courses its departments have. This is probably more typical of the kind of business inquiries you get in a report. And it took me a while to write this one, probably about 15 minutes. And I went to press thinking I got the right results. And then I did a little bit of a spot check, and I said, this school's wrong. And what I forgot was the coalesce here, the coalesce to 0. Just a little missing coalesce, and I got all the wrong numbers. And I thought I was good at SQL. So anyway, it's difficult. Debugging this is hard. This will go in your source code repository. Every time you get a new developer, they're going to stare at this and say, what is this doing? You absolutely need side documentation for this thing. And as I said, an SQL expert, it's 10, 15 minutes, and even then you might make errors. There's no way a business analyst will be able to write this. And a visual query builder, I don't think so. So here's the corresponding HTSQL. The row definition is you want schools where there exists a program, or you want school. You can move the exist afterwards. It doesn't matter. I was breaking it up. This is the fun part. For each school, you want to return the school name, and you want to average something. What are you averaging? You're averaging stuff on the department table. What are you averaging What are you averaging in the department table? Well, the count of courses. Which courses? The courses with credits greater than 3. Yeah.
What difference would it make if you pushed the department not inside the count?
The department inside here?
Yeah. What if you said average of count of department.course department.course?
That would be an error.
That would be an error?
Because you have an aggregate of an aggregate without anything that you're an average of a yeah. Because the reason why what you're saying is moving the count over here and put the department inside. Is that what you're? Okay. In that case, you would have a count which is a singular value with respect to school, and you'd be applying an aggregate to a singular value. So that would be an error. Because your average in that case wouldn't do anything. It would basically be averaging over a singular value, which would be the value itself in SQL. But otherwise, it's nonsensical if you're thinking about a business thing. Why would you need the average? It's completely redundant and non-functional.
I see your point, but I still find that department.count thing very hard to understand what that's actually supposed to be meaning.
Yeah, it takes a while. I think if you move from the inside, well, I don't know how else to explain it, but this is a complex business inquiry. That would be a lot harder to explain. Let me make one more pass at it. So you're returning schools. You're filtering them by to ones that exist in the program. That part's easy. You're returning name, and then you want to average something. So the argument of average has to be a plural expression where there's multiple values.
Yeah.
So what are those values? Well, you got to navigate down to you got to go somewhere in order to get those values. So you have to navigate. You're navigating from school down to department. So you have to navigate somewhere. So you can't just not navigate. So the department is actually kind of required right out of the gate. Because if you had another aggregate there, you'd by default have a singular value. And so in this case, you're going down to the department table, and you're calculating something which has a one-to-one correspondence with department. What are you calculating?
Oh, I see.
You're going down, you're counting something. So now that count is singular to department because it's an aggregate. Now you need something plural to department. What's plural to department? Courses. So you're returning course. Now what do you count? Now which courses? Ones with.
So that's definitely a lot less typing than what you have on the previous thing, and I think it's also conceptually simpler.
Yes.
But it's not simple.
No. Well, that's not simple. That's a complex business inquiry. This would never be answered this would always require a developer. Where we have business analysts writing those all the time. In fact, they get much more complicated than that after they get good at it, which is, this is why I always have very, very complex queries coming, and I'm like, oh no, you have no idea how big the queries we have are. Because we have queries in HTSQL that go on for pages, which means the corresponding SQL is brutal. I think actually in some ways that's a good thing, because these are problems that would take developers days to write, and analysts are able to do it in a couple hours. So, okay, I actually want to talk about a real use case. Why would you ever want to do this? And I want to talk about a business scaling problem that's corresponding to this. So, RexDB is the flagship product of Prometheus Research. We do medical informatics, and it allows us to, we collect lots of data for medical research labs. And one of the things that we have in medical research is that you're collecting data from lots of sources, and the most important thing to do is get the data in the database. It doesn't matter how clean or dirty it is. Getting in the database is the first start, because if it's not in the database, it's in someone's spreadsheet. And if it's in someone's spreadsheet, it's not shareable, and you can't track it, and you can't, you lose all your accountability. So dirty data is permitted in the database. Otherwise, you couldn't load it. I mean, yes, you could set up a bunch of cleaning processes. I mean, I'm just saying this is the tack I take. You could take a different one where you restrict it and make sure no bad data ever gets into the database. I think that's completely unrealistic. So our system doesn't take that approach, especially since what is valid data changes over time. When you talk to the user, the next thing they tell you is you got a bunch of data that's wrong. What do? Do you rip the data out because your rule is that only valid data goes in the database? So we have a constraint system which reports on bad data. And the core hierarchy is family, individual, and measurement. A measurement is a medical instrument given to an individual. The critical part of this is reporting on a subject's process through phases of quality, and we use constraints to do that. So let me move on to the actual problem. So in the constraint report, we have a tabular query. Depending on the particular problem, you may want to know what families have issues, what individuals have issues, and what measures have issues. And you may want to filter on those. Say, oh no, I'm only interested in families in this particular study, and I'm only interested in male individuals within those families. So the set of the criteria, the filter by which you may want to run, even the rows, the kind of rows you may want to run on those differs based upon what you're looking to check, which families you want to check. Similarly, there's a cross product. You have all the columns and each check you want to run. So each of these checks we've modeled as a column, which is completely orthogonal. So basically, the checks are predicate logics, which are often aggregates. They're often saying, hey, an individual is good if they have this kind of measurement with this score, that kind of measurement with this score, and that score is less than this score, and then something else was done. So a lot of these checks actually do involve aggregations that are fairly complex. So the key part here, though, is that each one of the checks is an isolated individual object or an isolated individual thing that you're doing, or a column selection, and that the filter criteria is done much later on down the process. So we have an intermediate auto construction of this HTSQL, which adds another layer, where we have a constraint system where you can define all your constraints, and there's hundreds and hundreds of constraints. And you pick the constraints you're interested in, then you pick the families you're interested in, and it runs this cross-product report in order to say what's wrong with those constraints on those individuals, or families, or measures. So here's kind of what the queries look like. If you have an individual, and you're running check 1, check 2, and you're putting some filter saying you only want ones in this study or that study, or ones with blood samples. And here's a more concrete version of this. And we introduced, we have a feature in HTSQL which we call define, because it's a little bit easier to define these checks in advance. You can think of it as similar as a CTE, but it's just variable substitution. And SQL could really use something a little bit more higher level than CTEs for refactoring. In this case, we want individuals where there is a pair, and one check is SRS 13 pair. This is basically saying, hey, in the SRS measure, the question 13 has to have a pairing over with an ADIR or something like this. So they're saying, hey, there doesn't exist an SRS measure, which is a subtable of individual, where question 3 is greater than 24 and question 1 is greater than 7. That's the existence check. And there's hundreds of these things. And then you basically, then you have your filter. This particular user was only interested in males in the AEI study. So then this query is basically compiled and run. The SQL generated, although kind of complex, is fairly straightforward to look at and debug. The SQL generated is actually kind of clean, but writing this thing directly in SQL would have been just impossible. We wouldn't have been able to develop the feature in a couple weeks that it took us to do it. So.
I don't see what that define thing is doing.
It's just variable. It's straightforward macro, nothing else. It's just so that I can document what the columns are. That's it.
Oh, I see.
It's just it's straightforward macros. It's just a macro mechanism. It actually doesn't impact the query at all. You can just substitute it in, and you're fine. So anyway, the idea of separating column definition from row filtering from the row definition, or the column selection from the row definition, is really important, and that's what enables this report to work. So anyway, that's it for the first part of the talk. Like, what is it? Why is, how does it go about doing it? Let's talk a little bit. Let me just run through a little bit about how you might want to use it, and then I could go over and do a bunch of sample queries. We can look at some SQL, and I can answer your questions. So anyway, there's several ways you can use it. First of all, you can use it like pSQL, which is kind of cool. Second one, you can use it as a Python library with Postgres, SQLite, or whatever. This is actually kind of fun. It has nothing to do with Postgres, but a lot of people load a CSV file with SQLite and rip and tear it, which is a use case I never thought of. But as a web service, you can run it in process with Django, or if you can have a Ruby process and a Python process and run them just in parallel using your integration at the web service layer. When you connect to your web service, authentication happens, encryption happens, and then if it has a particular URL, it goes off to HTSQL. Otherwise, it goes into Ruby. So you can build dashboards and stuff in parallel. So there's lots of combinations. It's a low-level tool. It's not. There is very little high-level packaging at this point. We'll probably add packaging later on next year. So you probably at this point in time, it's a Python package. It's easy to install. There are very few dependencies. It works beautifully with Postgres. But so command line, straightforward. You just HTSQL shell, connect PGSQL and then the database, and then you just type in your queries. Python, this would be how you do it. You just import HTSQL and connect to your database, and then you could get your data out in Python. As a web service, you start it up, and you can get some simple HTML, CSV. We'll be adding other formats later. And the development status. It's actually really mature. And we just crossed off that one. We now have catalog. We now have catalog introspection. We now have a way to add custom commands. What we want to add is support for record-based CRUD operations. That's the next few months, and we really want to get to hierarchical queries. And in Postgres, a lot of times you want to go /family/ or let's say using the schema you want to do /school/department. And what you want is a hierarchical result set to come back, where your top-level rows are schools, and then you have an array called department, which has all the department records. We will implement this as two separate queries with a hash join in the middle. The reason why is that, well, we can't implement the full grammar if we do it any other way. So each individual query is pushing about as far as we can. So how do you get it? Our licensing is a little interesting. I needed some funding in order to proceed with this, and I talked to the business people in our company, and they wanted some way to get a product revenue out of it. So we had two options. We could have gone with a GPL and tried to do a dual licensing, but we had lots of developers who were Postgres developers who I really wanted to be able to use the product without, and they wouldn't use it if it were GPL. So what we did is went with a non-OSI compliant license, which is a BSD license, and it has an exception that says you can't use it with a commercially licensed database such as Microsoft SQL Server or Oracle. This would allow a dual licensing strategy. I don't know how that'll pan out. If it doesn't pan out, it'll probably all be MIT licensed, so that there's just no restrictions at all. But we figured that this was an easier license than a GPL for people who are building applications with Postgres and SQLite, and so that's why we went with it. But it has one downside: we can't get in Debian by default, so we'll have to make a separate dev file you can download. So that's the penalty we pay. Source code is up on Bitbucket. There's no restrictions at all on commercial apps. We hang out in #HTSQL on Freenode. So I'm CCE, Kirill is RZ on Freenode, and we are trying to get users for Microsoft SQL Server and Oracle. The ports to the commercial databases are really not anywhere near as mature as Postgres. So if you actually have a commercial database, we could probably waive the licensing fee for someone who wants to be a alpha tester. So, okay. The other thing I would mention is that a lot of this work was funded by the Simons Foundation, who does autism research, and the National Science Foundation. So, okay, so that's about it. What I figured I could do, and what I was trying to get done before this was go over to a visual query builder, or not a query builder, but it worked great earlier, and then as soon as you actually try to use it, it doesn't work. So, but we can try it online. Let me just go right to, so, where is this? Okay. So our website is kind of fun to get to.
Especially through the hotel wireless.
Especially through the hotel wireless. So actually, let me show you some of the resources that are there if we can. If we can't, then I'll use the command line. All right, well, the hotel wireless was working well. Well, we have a beautiful, wonderful query builder that doesn't work because of caching. Let me just use the command line shell. So if you, just because I know you guys are going to ask about things, so let's just get this set, big font. This way we can type in queries. So very simple queries, hello world. And here is the SQL. Well, the SQL's below it for convenience. So, all right, why don't I just open up? I could walk through a whole bunch of queries if that makes sense, or I could just field questions. So what do we prefer? Let's just open it for questions, and then I could do a walkthrough later on if we have time. You may want to actually stick around for some of the queries if you have time. I don't know.
Actually, my priority list is rapidly shuffling lunch to the
top.
Of the
All right.
stack, so.
All right. Well, are there any questions or?
You showed Python being able to connect.
Python, because it's written in Python, you can connect directly. If you have SQL or Alchemy or Django, it's actually quite easy to integrate. Actually, even if you have Ruby, you can integrate. It's just at the web service layer. But yeah, you can call it right from Python and start up. And if you have SQL Alchemy, there's a plugin that will grab SQL Alchemy's metadata schema. When HTSQL starts up, it introspects the database schema to know what all the links are. And my ISAM for MySQL, those aren't there. So you need to for SQL Alchemy over my ISAM, you can grab the metadata you need from SQL Alchemy. So.
How easy is it from Ruby?
How what?
How easy is it?
Well, from Ruby, there's two ways you can do it from Ruby. One of them is just a shell out as a subprocess, which isn't great. Or the second one is that just at a web service layer, anything that you just look at your web services like ~x, that gets, or tilde, username, gets redirected over to the HTSQL process, which runs it. Yeah, but using it, one way you could do it, I suppose, is use HTSQL. You could use HTSQL as a compiler. So you have all your HTSQL queries in one folder, and you do make, and it makes all the SQL. So if you could probably write a little loader, and at compile time or build time, you could have all your business inquiries in one directory, each one in a separate file with a name, and then just reference it by name in Ruby if you want to pull it in, and then you're actually getting the SQL. The only thing that would stop you from doing that right now is that we don't have a mode to pass through parameters, but we might be able to add that. And that way you can move the whole query generation for any language up to compile time, which could be kind of fun. You still have to connect right now. You still have to have a schema. So the other thing you need from Ruby is the same thing as like an SQL alchemy. You'd want, Ruby actually doesn't make foreign key constraints. So the other thing you'd have to do is some way to export, look at your Ruby configuration and export the linkage configuration so that HTSQL knows what all the foreign key constraints are. So at least I think I'm correct. I was told that Ruby doesn't actually make foreign key constraints, but I don't know. So that's hearsay.
Can we use like an active record in Ruby to check? Can we use active record? Ruby has active record.
As long as you can get at the metadata and export it into a flat file, then you can tell HTSQL to start up with that configuration. So it'll probably take some work to make a Ruby adapter. I might be able to get to it in the next few months. So because I would prefer if Ruby people could use it too, because it complements ORMs very well. And also, I want to get this up and working with Heroku. And most of the apps there are Ruby apps due to historical purposes. And it would be great to run HTSQL, on Heroku. And if it's not if the foreign keys aren't there, I was talking to Peter that we might be able to write a small little Ruby program that uses the comment feature in Postgres to stuff all the metadata information. And then when the Python process attach, it can just read all the table comments and use that to construct the graph, the metadata graph. So the kind of queries, well, any other questions?
How long does it typically take the analyst to get up to speed with this?
That's a really good question. Internally, we use a much older version, which really sucks compared to the current one. But we still use it because it's going to take a while for us to migrate all of our software off of it. So this is a lot of lessons learned. The old system had 2 or 3 simple query builders that as you click and you build your query, the URL is constructed below. And that we found is an amazing learning tool. Typically, with about a week of just casual usage, maybe half an hour, 15 minutes here and there, users actually stop using the query builder and just start using a text editor with syntax highlighting instead. Because it's, but you have to know the primary, learning the syntax actually is a little bit difficult, and there's an anxiety curve. Once you get over the anxiety curve, it goes fast. They just start to use it. That anxiety curve, you really kind of need a visual query builder in order to get over, and we don't have that yet. So that's a problem. I mean, that's an adoption issue that we have. The other part is even if you know the syntax, you often don't know the schema, the column names, and what all the joins are. And we'll be adding completion to the command line in the next couple weeks. So that'll help, where you just do like control space, and it'll give you a pop-up of all the completions. That will help out immensely. Because especially if you're working with multiple schemas or very complicated schemas, it's hard to know where you can go. That's also a place where Visual Query Builder helps. If you're you have a nice pretty graph of the structure and you just click in your navigation, like your table that you're driving from has a nice little ants walking around it, right? And then you click to your related tables, and if they're singular, you can put columns right in. If they're plural, you need aggregates. So, yeah, I think that's one of the big problems we have in me running around. I was thinking about going out to more user groups. This is a fairly technical conference, so, but it's hard to push to actual data analysts yet because of the lack of a query builder. Yes?
Are there any limitations in the number of joins or projections that it would take in building the select SQL query?
Not in here, no. And Postgres actually handles an amazing number of joins. But whenever I talk to Robert Haas or Greg Smith, they're like, ah! But actually Postgres stuns me, especially compared to the other databases. Postgres returns results in things that you would never think would be possible. Where like all the other databases I know just die. And the other thing is that there's some fairly simple constructs that Microsoft SQL Server doesn't support. And you're like, how come you can't do it's a select within a filter within, or a join within a subquery, or something like that? Something like that it doesn't support. So we actually have to find a workaround for very simple joins for Microsoft SQL Server. I don't know if we can actually even work around it. I think they're just queries in the relational algebra you can't do with Microsoft SQL Server. So But I'm constantly surprised by Postgres and what it does.
I switched to Postgres because I was using a competing database product, and I got up to 6 or 8 table joins, and it just fell over. And I was like, I could spend time optimizing this, but I don't want to.
Why?
So
Yeah.
I tried it on an ancient version of Postgres, which was like
And it worked.
7 point something.
Yeah.
And it worked.
Yeah.
I have since run 34 table joins on production systems and gotten answers in a second or two, which is fast enough to put it inside of a web application. So, 34 table, you can answer really complicated questions with a 34 table join, as it turns out. And actually, one of the reasons why I worked on join removal for 9.0 is because I wanted to have even bigger joins than that, and they were getting too slow.
What kind of questions are you being asked in the right at 34 joining?
Well, what it really was is in here, what he has is he has this syntax where he's got like some other table, pulling a column from some other table, and that's really what it was. Like I would have a base table where I'm displaying schools, or I'm displaying contracts, or I'm displaying people. But then somebody wants to know, okay, so for this project, follow the project to the contract, follow the contract to the organization, then get the project manager, and then get the project manager's name, and show that on this report. And so I made a query builder that is a completely different philosophy from his query builder, where people would just check off the boxes, the pieces of information that they wanted to display. And it works great, but you have to have this enormous view that pulls in all of these subsidiary tables that most of the time the person doesn't check the box. And so, but you're still paying the penalty of joining to that table. So it was either build something like this, which I didn't want to do.
Oh, this took forever to build.
Or get join removal in Postgres so that I can still have the joins all in the view, but not actually have to evaluate them all, except for the ones that pertain to the columns that were actually selected. Now, as it turns out, that company went out of business, and I started hacking on Postgres full time. So I haven't actually gotten to play with the technology and see how much further I can push it out. But I'm sure that bought me another 15 or 20 tables for the next time I have to go build one of these things.
We actually learned something from Jim Nasby that's kind of cool. A lot of his queries, let's say you want programs. So, okay, so in the program table, there are distinct degrees. So there's BA, BS. And one thing that's kind of fun that we just added was if you count programs where the degree equals BA, you know.
Is that a correct syntax there?
No, equals. And count program where degree equals BS. This is kind of fun. This is an optimization that we added which speeds things up a lot, where it does a case when. We're moving, whenever we can, we actually move the sub-predicates to join frames, to reuse the same join frame and using a case when.
Well, there's several ways to write that query depending on what you think is going to happen.
Yeah. Yeah.
So that's one of them.
That's one of them.
And it's not a bad one.
No, but this performs better than joining twice in almost every database.
Where this kills you is when you have a highly selective predicate
Yes.
on the school table. And then you went and you computed this for all of the programs for all of the schools, even though, as it turns out, you only need it for the 3 out of 10,000
Right.
So it's actually very difficult to get this kind of thing right in general. Your way is good, but it is possible to construct a scenario where this falls.
Actually, in this case, the left outer join is done unless you actually have a join back, an explicit join back. And if you have an explicit join back, then it won't use this technique. So, but yeah, no.
But a filter condition,
it won't always work.
a
Yeah.
filter condition on the outer school